Once again, this is Mr. Santana, and I wanted to just go over how to get an equation from 2 points that are representative of a linear relationship from the coordinates that are given here. Now, you could derive the coordinates from a graph, but right now in this problem, they are presented to us in the problem itself. So it says here, points 6, -2 and -3, -5 are on a line that represents a linear relationship. What equation represents this line? And then you're asked to show your work. So if you've been following along, you know that for us, writing the equation right here, which is what we're asked to do, it's going to look like this: y equals mx plus b. Now, this right here is slope-intercept form. There are other forms for a linear relationship, but for our intents and purposes, we need to write it like that, right? So this is where you must start, right? You need to get this first. This is the first thing you're going to get. And then this is the second thing you're going to get, right? Those are your two steps. And then the last thing is to put the equation together, but for now, it's really just two steps and then just replacing m and b. So let's start working on m. As you know, m represents the word slope or rate of change, in which case you have to know how y changes as x is changing. So in order to do that, you have to divide the change in y over the change in x. So first things first is you have to identify what's what. So let's call this the first point over here. Let's use a different color just for the purposes of making sure we are clear. This is point 1, and let's call this point 2. So you know that all points or all coordinates are written in this fashion: x comma y. And so we know y coming from the second point is going to be -5, and you have to take that away from y coming from the first point, which is -2. And then you have to divide that result by the second x, which is -3, minus the first x, which is 6. All right, so that is what the slope is supposed to be. That is the formula: y2 minus, or sorry, second y minus first y, and then second x minus first x. So when you subtract this, -5 take away -2, you end up with -3. And then -3 take away 6 gives you -9. Now feel free to check that on your calculator. Know that when you simplify this, you end up with 1/3. Again, you can do that on your calculator, okay? So now we know what m is. That means we literally are, and let me write it over here, right? Because I don't want to erase that other piece. It definitely is important for us to know what we're writing and where it comes from. So we just figured out that m is 1/3 right here, right? So m is 1/3. So I want to go back here and definitely just use that. So wait, I need the eraser. I'm going to erase m, and I'm going to write in its place 1/3, because that's what I just calculated it to be. So y equals 1/3 x plus b. So now you get to choose whatever point you want. You can use the first point, you can use the second point. It really isn't going to matter, because they both should give you the same thing, because we're going to solve for b. So first and foremost, I'm going to use this one, which is 6, -2. And again, I'm going to remind you that x is first and then y goes second. So looking at that point, I know that y is -2, so I'm going to replace y with -2. So now this equation became -2 equals 1/3 x plus b. So same thing, I'm going to erase this, and I'm going to write instead times 6, because anytime a number is in front of a variable, that means multiply. So this is 1/3 x, or 1/3 times 6 in this particular circumstance. So now you first have to do this. Let me borrow this blue color here. I want to solve this piece first. See this right here? That piece right there, if I type that in my calculator, I'm going to get 2. So this gives me 2. So 2 plus b has to be equal to -2. At this point, the only way to solve this is to use inverse operations, and maybe it's not the only way, but definitely one of the ways that can be solved. It is definitely going to give you your result, right? So I go back here, sorry, and I know that 2 take away 2, I can cross out because that's going to equal to 0, and then 0 plus b is just b. And that comes down there because 0 plus b is b. And -2 minus 2 becomes -4. So in this case, b is -4. So now I just have to put the two things that I discovered, or that I calculated. I didn't really discover it, right? That I calculated it. So this was m. This is b. So I'm going to take this equation and I'm just replacing those two things. Those are the only two things I'm replacing. I keep going back to that. All right, there you go. So it's going to be y equals, m, remember, is 1/3. So 1/3 x, and plus b, it would be plus -4. But we can write plus -4. I'll write it out for you. But notice it kind of leads to some confusion. So you either do this, right? Or you just write -4 because it is equivalent to plus -4. So your final equation that represents the line that goes through those 2 points is y equals 1/3 x minus 4. So I'll say this. If you feel compelled to run a check, and you don't necessarily have to, I would use the other point, right? So the other point is -3, 5. I'm sorry, -5. And I know that x is -3. So x is -3, and if I put that in here, right, I'm going to get this. 1/3 times -3 minus 4. When you calculate 1/3 times -3, you get -1. And then you bring down the -4 because I didn't do anything with that. -1 minus 4 gives you -5. So y was here all along, right? If I bring this down, because nothing has changed, y equals -5. It works out. You actually get the number that goes on the other side. That is a good way to check if you feel compelled to do so. And you will make sure that you have the correct equation. And that's all you have to do.